So probably in your statics of rigid bodies, so I think that you have solved different reactions in different scenarios. So in this case, so what you have solved in your statics before is that you were able to solve forces using the three equilibrium equations. So what are these three equilibrium equations? So probably you know them by heart since you have already passed statics of rigid bodies. So you may remember this one as the summation of moments equals 0. Then you have the summation of forces horizontal equals 0. Summation of forces vertical equals 0. So these are the three equilibrium equations. So if we say that our members are statically indeterminate, so if you say it's statically determinate members, not indeterminate, so meaning you can solve forces, or let's say the unknown forces are equal to the 3 or lesser than the 3 equilibrium forces. But if the unknown forces is greater, so let's say the unknown forces is greater than the 3 equilibrium equations, meaning our scenario is statically indeterminate. So let's say you're going to have 4 unknowns, then you're only presented with 3 equations, so you cannot solve them using the 3 equations alone. So you need other modes or other formulas that you need to incorporate in your solution for you to be able to solve statically indeterminate members. So most likely in your theory of structures, you'll be dealing with purely indeterminate members. So dito na masud ang mga different types of techniques such as the 3-moment equation, may mga daghan na kay mga other methods of solving statically indeterminate members. So muna siya. So basta magkadugay, magkalabad ang kaning mechanics. So in most cases, mag-solve na mo og tag-upat ka moments ana. And then daghan kayo mga vertical forces, horizontal forces. So at least hopefully by that time comes di kayo mo maglisod because you know the basic concept of indeterminate members. So to begin with, so these are members that contain more unknowns. So again, as what I have told you earlier, more unknowns compared with the available equilibrium equation. So as far as we know, we only have 3 equilibrium equations: moment, vertical forces, and then horizontal forces. Diba? So again, if there are more unknowns, we are having a statically indeterminate situation. So to fully analyze these members, so additional equations must be derived. So most likely, this is what we call as the kaning deformations na mga formulas, or in other terms, we call it as conditional na mga equations. And these conditional equations are being derived from your Hooke's law, your atong mga strain and deformation formulas. So dito ta manguha sa inyohang mga different formulas. So usually katong play formula na katong PL over AE. So mato siya atong mga gamiton na formula, and most likely the other concept or the other term for these equations are what we call as compatibility equations. Compatibility equations. So again, these are coming from the strain and the deformation, strain elongation formula. Okay, so most likely the popular formula that we utilize more is kaning elongation, which is katong delta nila, small gamma, small case delta. So PL over AE. So this is what is most likely that will recur in our different problems. Okay. So again, we utilize these compatibility equations for us to create another geometry that will result to the forces of your members being solved. So I think there's no other way to appreciate this topic but to solve some problems. So if you think of statically indeterminate members, so we're going to gather all that we have discussed before: stresses, simple stress, simple strain, and we apply it in this problem. Also the knowledge that we have gained from statics of rigid bodies, which is solving reactions, diba? So we need those inputs for us to be able to solve this statically indeterminate member. So again, statics 1, other static subject, static course, especially solving reactions, getting the FBD, the free body diagram, then formulas coming from simple stress and simple strain. So as what we have discussed so far. So those are all important in solving these equations. Okay, so in this problem, we have a rigid beam. So let's say the mass is negligible. So there's no added weight in the system. So if it has a weight, so meaning you have to add another parameter or a force being applied at the middle part of the rigid beam. So one is pinned at the end and supported by 2 rods, which is made of steel and aluminum. So also given in the diagram, the different parameters for steel and aluminum. So area, modulus of elasticity, and its length. So the beam was initially horizontal before the load P was applied. So the beam is horizontal, meaning there's no movement, there's no deflection, there's no um, elongation of the steel and aluminum rods happening. But upon the application of the 120 load kilonewton, so meaning na siya ikuan, di ba? So next is we need to compute for the elongation of the steel rod, meaning this section here. Next is the elongation of the aluminum rod, so this part here. And we also have to get the movement of P, so meaning this portion here. We don't know yet the exact behavior, but since it's looking for a vertical movement, so it may be upwards or downwards. So most likely the movement will be downwards because the force is going downward. So it's being pulled down. So we expect that the steel and aluminum rods will be elongated. So there will be an elongation. So for this part here, probably it will depress, diba? Na depression. So we call it depression lang kay it's not elongating, diba? Bali ni os lang siya or ni deflect. Depression or deflection. So I think that's important on how to visualize your problem. You have to know the behavior of the different elements in your structure. So again, I cannot say that there's a one-way rule for knowing the behavior of materials, but again, you have to imagine it that pag mo elongate siya, mo kuan siya. So mana siya, so you need to visualize whether the different parts are in compressing, mo elongate ba siya, in tension ba siya. So that would be on your prerogative on how you're going to analyze your different members or parts of your members. Okay, so let's start off with this diagram. So again, probably since P is going downwards, so let's say the behavior of your steel bar, or rather your rigid beam, is going this way, di ba? More siya ni deflect kamay na. So let's say muna siya ang behavior. So we know that this one will be elongated by a certain degree, and this one also, and also for P, di ba? Na say deflection gamay sad. Okay. So of course we can say that the elongation for the aluminum or aluminium, di ba? Aluminium, so na pag properly pronounce na. So of course we can say that the aluminum is having aluminum mas larger ang iyang deflection because of course knowing that the modulus of elasticity between the two materials is a big difference, diba? 70 against 200. And then of course we know by fact that aluminum mga aluminum cans, diba, are easily deformed compared with steel, diba? So muna siya. So basta niya may buong mga ano mas dako og deflection ang aluminum compared with steel. Okay, so the first step is you have to get the compatibility equations first. So meaning we start off with the deflection. Okay, so for a while. So if you're going to start off with the deflection, so we might utilize first this kaning triangle. So rewriting the triangle again. Before tayo mag-start day, so we know by fact that it's statically indeterminate because if you try to get the FPD of this diagram, so let's say this is the beam. So we have two unknown reactions. We have a force coming from the steel section, coming from the aluminum section, and what is known is only the 120 kilonewton coming from P. So notice that we have here 4 unknowns. So 4 is greater than the 3 equilibrium equations. So meaning it's statically indeterminate. Okay. So that's how you analyze it on how you're going to determine whether it's statically indeterminate or not. Okay, so next step is we try to, so first step, so I'll try to write a number. Second step is we try to get its compatibility equation. So meaning the strain na mga equations or elongations na mga equations. So let's write first the triangle again according to the deflection. So let's say this one is 3 meters. And then going towards here is another 3, di ba? So this one is the deflection coming from the steel, deflection coming from the aluminum. Okay, so next is we're gonna do some ratio and proportion. So compatibility equations first. Or pwede sa rin nyo buhaton una ang katong equilibrium equations and then afterwards is the compatibility equations. But bisag asa ra ang pidira, bisag asa ang yung buhaton. So in my case, I just want to perform first the compatibility equations. Okay, para ma-force akong utok nga in every situation, I need to use those compatibility equations first before I'm going to use the equilibrium equations. Okay, atong equilibrium equations, okay, we know it by heart naman since we have it in statics of rigid bodies. But for strain equations, since we tend to ignore those topics, So after getting the equilibrium equations, we tend to ma-lost ta sa ato ang calculations on what to do next because we don't know kung unsa nga formula atong gamiton. So that's why we have to force our brain that after knowing that it's statically indeterminate, we have to look for strain equations first, compatibility equations. Katong mga deflection na mga formula. So ana. So we have here, so if you're going to write the ratio and proportion, so we have here the deflection coming from the steel divided by 3 is equal to the deflection of the aluminum all over 6. So if you try to, let's say, simplify the equation, so this would give us, so 3, 3, then this one is 2. So this would give us 2. The deflection of steel is equal to the deflection of aluminum. So this, so let's say this one is muna siya nga to ang equation, di ba? But dili pa jud totally muna atong equation. Okay, so next step is, again, since this one is the deflection of the aluminum is twice the steel. So sa atong objective ani. So since we don't know the forces coming from the steel and aluminum, so we have to do, what we have to do here is we try to further scrutinize the equations, meaning apply certain further equations in your kaning lines here para ato yung makita ang force P and force, the force coming from the steel and the force coming from the aluminum. So this one is 2. So again, as per the formula of deflection, that's PL over AE, di ba? So this one is twice. So PL over AE of steel is equal to the PL over AE of the aluminum. Ana. So if we try to expand it further, so this would be 2. So bracket. So I'm going to put bracket because I'm going to put parentheses inside the other formulas. So for force of the steel, that would be P sub ST. So for the length, we know that the length is 4 meters. So again, shortcut version, di ba? Shortcut version, gigapascal is kilonewton per mm squared. Okay. So meaning the other parameter should be in millimeters para akong force is in kilonewtons now. Or if you want it in newtons, megapascal is equal to newton per mm squared. Shortcut. So again, PST, so that would be times the length. So in terms of millimeters, so this one is now 4,000 millimeters divided by the area, which is 600 millimeters squared. So again, I want my answer to be in kilonewtons. So that's why I'm going to put 200 GPa, gigapascal, 200 gigapascal. Then equals the right side, which is PL over AE still, PAL times the length of the aluminum, that would be 3,000 divided by the area 900, then times 70. Okay. Okay, so this will give us 1 over 15 PST. Then the other one is, that's 2 over 15. Sakto na siya, 1 over 15. And then the other one is 1 over 21 P aluminum. So you may write this in this format, or you may try to isolate the other one. So 21 over 15 meron na. So if we try to simplify this one, you're going to have 1.4. The force of steel is equal to the force of aluminum. And we try to try to make this as our equation number 1. Ito lang i-box para ito makita. Okay, so now since we have our compatibility equation coming from the strain na topic, so the next step is for you to be able to use one equilibrium equations for you to be able to solve your forces. So we have here summation of moments, let's say about the joint. So let's say it's about O lang siguro, is equal to 0. So again, counterclockwise is positive. So let's say this is point O, di ba? So 3 meters, 2 meters, and then 1 meter. So summation forces 0. So again, the first one coming from PST, it's counterclockwise. So I mean, that's plus. From P, that's minus. And then from aluminum, that's plus. So you're going to have force coming from steel times 3 meters. Okay. And then minus 120 times 5. Then plus P aluminum is equal to, or rather multiplied by 6 equals 0. So we have 3P steel plus 6P aluminum, and then let's say equals on the right side, that would give us 600. So looking at the equation, it's all divisible by 3. So let's try to divide by 3. So P steel plus 2 aluminum, P aluminum is equal to 200. So you may express this as your equation number 2. So notice that we now have 2 different equations. Diba? So we can incorporate one with the other. Diba? So sige. I can't hear you properly kay mas ako pagtingog ang ero.
Okay, sir, nakuha na din ako. I was supposed to ask the asa na ko 120 ba?
120. Oh, sige. So 120 is coming from the force, ha?
Okay, sir.
Okay. So after getting the compatibility equation, step number 2, and then the equilibrium equation, step number 3. So after having 2 equations, so you now have to incorporate one equation with the other. So for example, using equation number 2, so let's say equation 2 to 1, let's say that's the one. So balide. So equation 1 to 2 data. Okay, 1 is simpler, and then you just plug it in the equation number 2. So equation 1, you apply it to equation 2. So P steel, so notice that P aluminum is just 1/4 of the force of steel. So if we try to incorporate that one in our equation, so we're going to have P steel plus 2 times 1/4 of P steel is equal to 200. Okay, so 2.4, 2.8. So we have 3.8 steel is equal to 200, and then divided by 3.8. So steel is equal to, so pila man ang steel?
52.63, sir.
So 52.63 kilonewtons. So again, it's kilonewtons because it's coming from 200 kilonewton per meter. Then divided by meter, so that's why it's only kilonewton. So now it's using equation 1. So P aluminum is just equal to 1/4 of P steel. So this is 1/4 multiplied by 52.63. So P aluminum is equal to
13.16, sir.
13. Multiply.
I multiply. Yes, sir. I 1.4. 73.68, sir.
So 73.68
1/4 akong nabutang, sir. Sorry.
kilonewtons. Okay. So now we have the force coming from the steel and the force coming from the aluminum. And again, as per the first question, we're going to find the elongation of the steel rod, the elongation of the aluminum rod, and the vertical movement of P. So meaning na, okay na to, di ba? Because we just have to deal it individually now. Okay, naram tayo force coming from steel, force coming from aluminum. So since wala may space, no, okay. So just let me write it here on the lower left lang siguro. So next step is to apply the constraints at different kanang kuha na. So elongation of the steel rod, that would be PL over AE. So automatic na siya, di ba? Okay, kanam tayo force. So force coming from the steel is 52.63 kilonewtons. And multiplied by 4,000. Then area is 600, then 200. Then you have the deformation of the steel. So deformation of the aluminum, same as formula PL over AE. So that would give us 73.68. Then multiplied by 3 meters, that would be 3,000 divided by the area, 900 mm squared, then 70 gigapascal. So probably the vertical movement of P, you may have to just use ratio and proportion. So you just try to add another triangle here, then this should be the deflection of P. So 5 meters siya, di ba? So, so mapuno lang siya diri dapita na P all over 5. So pila ang deflection sa steel?
1.75, sir.
So 1.75 millimeters. So again, it's automatically millimeters because I set the equations in terms of this one, kilonewton per mm squared. So akong forces in kilonewtons, then ako ang E is in gigapascal. Then for aluminum, how much is aluminum?
3.51, sir.
3.51. So for the movement of the force P, so just try to solve it on your own na kayo maragwa na space sa screen. So, but mo na siya. You just have to add it in the triangle. Then use ratio and proportion to solve the deflection at P. Since we know that the deflection of the other two materials, so most likely complete na ang triangle, diba? Except for the deflection at P. So you may use this. Okay, so questions for the first problem. So again, to summarize the steps, most likely, ang kaniyang first step, pwede rin siya dili siya i-present as long as you know that your member is statically indeterminate. So pwede rin siya wala. So again, the first one would be compatibility equations. Compatibility. Narrow spelling. Compatibility. The next is equilibrium equations. Equilibrium. Then after solving for the forces, then that's it. You have to use basic concepts of simple stress and simple strain in order to solve the asked items in the problem. So marag mo na siya compatibility and then equilibrium forces. Or vice versa, depending on your comfort zone, whether you're comfortable with setting the equation first using equilibrium equations or the other way around, diba? So it depends on the person. If you're more comfortable with setting the equilibrium first rather than compatibility, so go ahead. It gives you the same answer, Gapon. But again, in my case, I want to force myself that I need to look for the compatibility equations first before the equilibrium. Kaya ang kanang equilibrium is always present man, di ba? I think up until you reach steel design, you're still going to have to use the equilibrium equations compared with the strain equations, which is rarely used at that point. All right. So this is the solution. So yeah, is PA lang siya because that is the aluminum part for the solution. So P sub A is the aluminum and then P sub S is the steel. So muna siya ang iyang first solution. So yeah, is summation moments about A lang siya. Okay, about okay, I don't know the left. Okay, then this is the deformation for deformation calculation. So again, after solving P sub S, so usually wala siya P sub A, di ba? Kay murag ang iyang pag-incorporate sa force sa aluminum is just by multiplying it by 1.4 here. But sa ako is I want to really make sure nga nandiyo ko force sa each element sa ako ang structure or member. Then again, this one is for the vertical movement of the load P. So you have to just utilize the right triangle, ratio and proportion. Okay, so do you have questions? So probably none. Okay, simple pa kayo siya, no? Okay, so let's move with the next example. So we have three steel eye bars. So usually, ang kanang pag-drawing ani is murag kanjo na siya. Usually, if you have steel eye bars, so gitawag siya eye because ang iyang tumoy murag mata kay it's being drilled by a certain hole ba, so mura siya kanang, so kanina siya di siya dapat square but it should be circle. Circle na siya dapat. So murag inana siya ang dagoy ana murag. So lagi mura siya ganang mo circle diri ana. Yan na siya lungag diri ana. Mana mga steel eye bars. So each by 100 by 25 mm in section. So meaning it's rectangular in section. Now we have, so it's assembled by driving a rigid 22 mm diameter drift pin. So di ba ganina square to atong drawing, di ba? So dapat circular siya kay usually the pin is in circular format. So the rigid bar is the rigid pin is 22 millimeters in diameter. So the center line spacing between holes is 10 meters. So for the outer, so kani siya out, kani siya middle part, then this one is outer. So for the outer bars, usually the spacing is 10 mm, but the spacing between the bar in the middle one is shorter by 1.1 mm. So as you notice, mura siya superly exaggerated nga drawing, no, kay murag dako kayo ang 1.1 millimeter. So again, 1.1 millimeter, that's 1 mm. So if you try to look that one up in your ruler or any measuring device, gamay kay na ang 1.1. So we just have to super exaggerate lang siguro sa drawing kay para mura siya kanang may movement gamay ba? Ba? So of course, upon drilling or let's say upon driving, probably there's some movement, ba? So sa may great example na sa inyong kuan. Diba, for example, mura mo mag-stapler o kuan, di ba? Mag-staple mo couple of pages. So di ba naman na yung ubang pages in the middle nga mag-diligent siya mo hanay sa inyong first page and back page, di ba? So there's some movement in between your papers, di ba? So murag ana na pud siya nga concept. So upon driving the pin through your steel eye bars, so probably there's some movement in the middle part of your steel eye bar. So that's why it causes it to move away 1.1 millimeters, or so murag inana siya na concept. Okay, so find the shearing stress developed in the pin. Find the axial stress in the outer bar. Find the axial stress in the middle bar. So meaning, if we try to draw again our kaning at the end part, kaning end portion, if we try to draw it again, so most likely the pin is in this format. Let's say, siya yung 3 steel eye bars. So ako lang siyang ikuha na sumpay daan. Then I'll just let another color be the pin. So let's say this is the pin, di ba? Yeah, let's super exaggerate the 1.1 mm. Mas ana di siya, di ba? Kanya kay super exaggerate na siya. Then ibalik sa original, di ba? Eh, straight naman siyang alungag, di ba? So ang outer diri, yung outer dito tupong. Pero diri sa tunga, dili tupong kay it's away by 1.1 millimeters. Okay, so again, since it's looking for the axial stress, so notice that since this one is going bar, shorten siya by 1.1 millimeters, diba? Nigamay siya 1.1 millimeters. So probably the force is going this way. It's a bar. Then this one is probably just okay because hash is a right spot ng inyong. So we can call this as P outer. This one as P middle. This one is also P outer. So yan na siya pagka-present sa inyong problem. So again, it's all about knowing some items in the problem. So getting to know the problem first, diba? Before getting into the solution. So of course, once you answer different types of problems, you have to encounter different types of scenarios. So for example, kaning 3 steel I bars, at first glance, Google search engine, so you may be able to appreciate what steel I bars are. Yeah, probably the next question you come into mind kay ano mo move man siya og 1.1 mm, di ba? Upon driving the pin. So dapat ug mo drive kag pin, there's no movement or no deflection, di ba? So mag-anar sa na yung concept. So let's say na you relate it with other stuff. Let's say katong pag-staple sa paper, di ba? So it's not really a perfect stapled paper because there are some movements along the process of the driving of the staple wire. So example, kanasang pag drives a nail between two woods, di ba? So in most cases, we try to make it stable as much as possible para walay movement sa second na kuan, di ba? Na wood. So ana. So just try to answer more problems because you'll be able to know more with different scenarios for this particular topic. So most likely mo ni siya ang topic nga maghatag jud ko og okay. Compared with the simple stress and simple strain, so probably I'll just give you around 3 to 5 problems ato. Kani siya is mo na siya ang pinaka-importanting topic because this will recur and repeat in the following courses sa inyong kuan. So theory 1, theory 2, you'll be dealing with statically indeterminate members. Okay, so anyway, step number 1 is we try to create again our compatibility equations. So to do that, notice that we have 1.1 millimeters, diba? So meaning from starting going towards here, that's 1.1. Okay, so let's split it into two portions. The deflection caused by the outer bar and the deflection caused by the inner bar. So for our compatibility equations, we're going to have sigma sub outer plus sigma ba nila? Sigma delta is equal to 1.1 millimeters. Okay. So again, why did I add the two different deflections? Dili siya totally deflection, di ba? Because when you drive the pin, it's totally perpendicular to the cross-sectional area sa inyong 3 steel I bars. So again, probably the movement is caused by the axial forces, di ba? Katong akong i-draw ganina. So katong dire. Then this one is pulling, and then this one is pushing, di ba? So probably the movement is caused by those forces. So PO, PM, and then PO on the outer side. So this is what caused the 1.1 movement in difference between the outer and the middle portion of your one. So again, it's not totally that, di ba? Kung makita mo na ay murag hidden line diri, di ba? It looks like na symmetrical ang pagka-divide sa deflection at M and deflection at O. So again, M is mid bar, O is outer bar. So it's not really, so again, the drawing is just exaggerated for the purpose of knowing the behavior of the material. So it's not really accurate drawing, but again, it's the purpose of super exaggerating the drawing is that for you to appreciate the small deflection between members. Na, diba? Kaya again, 1.1 mm, if you try to look it in the ruler, super gamay kasi yan. So, basta hindi mo maka-appreciate sa value if you try to draw it to scale, di ba? So again, it's not
Hear you, sir.
Excuse me, sir. Hindi may kadungog mo, sir.
anak kong kwanda eh.
Karon, sir, nabalik na, sir. Pero
Okay.
ganina, sir, kay wala.
Anawa na sa day.
Ni-stop siya pag katong pag-explain nimo sa deflection outer plus deflection
Sige.
middle is equal to 1.1 millimeters, sir.
Sige, so going back, so again, when you try to look at the drawing, ano siya. So it's not really, so if you try to look at the hidden line here, so you may say it that it's symmetrical with the outer and middle nga deflection, di ba? But it's not really that symmetrical. So the purpose of the hidden bar here is not to set that the mid and the outer deflections are equal, but to give portions lang that na ay contribution ang outer deflection and middle nga deflection to the 1.1 mm difference sa steel bars, between steel bars. So nagasa ninyo? So ang katong 1.1 difference between the outer and the mid bar may be caused by the movement of the two steel eye bars. Ba? So probably nag-contribute ang kaning movement sa outer bar niyo and also for the inner bar. Ana. So again, if you try to imagine it, so probably in ang pag-drive sa 3 kabuk steel bars, so probably ang iyang purpose is kanang, let's say nakaset na dito ang inyong 3 steel eye bars, di ba? Then for the sake nga dapat ma-fix lang ang iyang endpoint, so someone siya pag-explain other terms. Let's say the 3 steel eye bars kay nakaset na sa inyong construction site, di ba? And all you have to do is to put a pin at this location para himo siyang restricted or para ma-fix ang iyang endpoint. Wala siya further movement. So probably the members are already experiencing some internal forces. So muna siyang explanation behind the 1.1 mm difference, di ba? So probably kani siya na siya pulling force daan, kani siya na siya outer force daan. Okay? So next is we utilize the formula PL over AE. So PL over AE of the outer bar. Then PL over AE of the mid bar is equal to 1.1 millimeters. Okay, so again, we try to utilize the formula. So na ba ito given na E? Okay, so what I given na E, you know? So let's say that E is just 200 gigapascal, okay, since it's steel. So E steel is 200 gigapascal. So applying the force, so we now have P sub O times the length of the outer bar, that would be 10 meters. So 10 meters, then multiply it by 1000 to make it millimeters, then divided by the cross-sectional area. which is 100 by 25 millimeters. Then multiplied by 200 gigapascal. So again, gigapascal is kilonewton per mm squared. Okay, so next is we go to P mid, the force at the mid bar. So instead of 10,000, so notice that it shortens by 1.1 mm, di ba? So instead of 10 meters atong gamiton for the mid bar, so we tend to subtract 1.1 mm to it since it's kanang shortened by that much, di ba? Di ba? Ni shorter man ang kon ang mid bar. So notice in the statement, shorter in the middle bar. So meaning ni
Excuse me, sir. Marag na wala imong mic.
okay. So I think na siya. Okay, so going back again. So instead of the force of the middle bar, rather the length being 10,000. So since it's shortened by 1.1 mm, so 10,000 minus 1.1 for the mid bar. Then since the area is the same, so it's 100 times 25. Then this one is times 200 equals 1.1 millimeters. Okay. So if we try to simplify this one, this would give us 0.02 P sub O plus this one would give us 0.0199978 P sub M equals 1.1. So this one is our equation number 1. Okay, so this is our compatibility equation. So next step is we go to our equilibrium equations. Okay. So for equilibrium equations, it's pretty simple. So since we have horizontal forces only, diba? As what I drew earlier, if this one is the 3 steel bars, but then let's say this is the pin. So muna siya itong mga horizontal forces. P sub O, P sub M, P sub O. Okay, so summation forces vertical, either horizontal, equals 0. So again, going that way is positive. So we have 2 POs. So that means PO is twice, then minus P sub M, that would be negative, going to the left, equals 0. So we have 2. So PM is just twice the outer force. Okay, so this is our equation number 2. Okay, so incorporating equation number 2 to 1. So using equation 2 and incorporate it to 1. So again, PM is twice PO. So 0.02 P sub O plus 0.0199978, then multiplied by twice PO is equal to 1.1. So notice that we have one variable only in the equation. So we can now solve for PO, which is equal to
And 33, sir.
So 18.33 kilonewtons. So for PM, so PM is just twice PO. So this would give us 2 times 18.33. So this would leave us 36.66 kilonewtons. So okay na, di ba? So we have PO, we have P sub M. So since we have the two forces now, so we can now solve for the asked items in the problem. So the shearing stress developed in the pin. So the pin is this one, di ba? Marsha katong nag-connect sa 3 kabuk plates. So of course, it's going to experience shear strain because, rather shear stress because the force is parallel to the area. So a young area is kaning circular, di ba? Circular pin. Okay, so for the shear stress at the pin, so let's say this is number 1. Shear stress at the pin is equal to force over area. So again, the force is coming from, so asa matong gamiton, ang 36 or ang 18.33? So muna siya ang biggest question, di ba? Since we are presented with 3 different types of forces and all are parallel to the with respect to the pin. So the question is, unsa atong gamiton na force, di ba? Is it 18.33 or kato inyohang atong 36 point kuan? Okay,
46, sir.
so what we're going to use is ang
36, sir.
ang 18. So the purpose why it's 18, because in the first place, the members are equally distributed, di ba? In terms of the shearing aspect. So di ba, if imo siyang itanahon, 18.33 is mo na siya ang nag-revolve around the pin, not the 36. Probably the 36.6 is what is causing the movement, but in totality, the pin is experiencing 18.33, di ba? But mas kusog lang siya sa middle part because it's twice 18.33. So 18.33 divided by the area. So pi d squared over 4. So usually in this case, I try to multiply it by 1,000. So instead of 18.33, ako siya imo og pwede po siya in kuansad in gigapascal, but wala mo siya, sige, gigapascal lang ta kay para kuan ditso na. So pi d squared over 4. So pi over 4 times d squared, that would be 22 millimeters. So the shear stress naman nun. The shear stress in the pin will be equal to, so pila naman? So if it's a small number, so probably try converting the kilonewtons to newtons para may mo siyang megapascal. Okay, if it's 0 point something, so meaning that would be in gigapascal because we are using kilonewtons. So again, keep in mind, so ako dyan siyang iswat pirme. Kilonewtons is mm squared na. So kani since kilonewton per mm squared man ta, so atong expected na gawas sa atong answer is gigapascal. But if it's a small number, so try using megapascal para medyo mudako gamay. Newton per mm squared.
And 22, sir.
Pila?
48.22.
So in megapascal na siya.
And megapascal, sir.
48.22 megapascal. Okay, so number 2 is axial stress in the bar. So again, axial stress, so meaning that would be the area should be perpendicular with respect to the force, diba? So axial stress, that would be axial stress at the outer bar. So again, force over area. So the force is 18.33. So again, let's make it in newtons para mudako ang answer. Then divided by the area. So again, the area is this one. 100 by 25. That's the stress at the outer bar. So for the inner bar, or rather for the mid bar, it's still the same. So kung ano siya axial stress, number 3 is axial stress niya siya. Axial stress. But 3 wala siya axial, no? So na siya axial stress there. So force over area, that would be 36,660 all over 100 by 25.
Seven 7.332, sir. Then
So, ano,
14.664.
megapascal. Okay. So muna siya ang 3 answers. Okay, so if okay naman mo kan or sige lang, try to pause it and the recording later. So para dugay-dugay sa gamay, okay? So again, to summarize our solution, we again did what we start off with the compatibility equation. So I hope I explained this a bit better. Ano inani siya nga pagka-present. The next is equilibrium equations. Then probably the third step would be incorporating the equations that you have derived from the first 2 steps by equation 1, equation 2. Then the rest is you can use basic concepts of stress and strain to solve different items. Okay, so this is the solution. So most likely the style that this book has considered kay murag katong di ba negative atong nakuha ani di ba 0.02 PO, then the other one is 0.019998 man to di ba, but yeah is he made it into a whole number. Okay, basin probably he doesn't want to deal with decimal coefficients. Okay, so this is the distribution of the forces. So again, this one is the pin. Okay, so 18.33 for the answer. Okay, so notice na medyo daghan siya kanang typo dere, but this one should be axial stress. This would be sigma. Sigma, and then this one should be sigma. And take note that this one shouldn't be minus 22. Bakay, if you're going to look at the cross-sectional area of the steel bar, so let's say, ana man na siya, di ba? So this is the 100 by 25 millimeters, di ba? So why do you need to take 200 away? I mean, rather 22 mm away. Nga ang pag-shorten sa 22 mm is in this axis man, di ba? Dili ang 100 na axis. So sayop niya siya sayop. So dapat kani siya is 14.66. So again, the shortage of the bar is not coming from the 100 millimeter nga axis, but it's on the 10 meter axis, di ba? Atong giminusan ganina, atong length. So kani siya din siya minus 22. Okay, so try to analyze this problem first. So I'll go to the comfort room for a while. So try to analyze the problem first, and then try on establishing the compatibility equation, and then next is the equilibrium equation. So di ba atong gigather ang atong mga gipang solve na problems before. So the same scenario, but it's just statically indeterminate. Okay, so try figuring it out on your own first. Okay, so na siya. Tanong ko nun dyan ang mic sa kung kan. But lang na something wrong pag order ani. So I think that's the downside of ordering in Shopee siguro. If you're ordering kanang mga techie na gadgets ba. Okay, if there's a problem, mura ang iyang pag-return would be kanang hassle kay siya ba. So better if you just buy it in Ayala or SM, kaya at least when there's a problem, dali kay siya mauli ba compared with kanang Shopee ana. So wapi ko ka-experience ng mga kanang kuan, kanang pag-return sa item sa Shopee o sa Lazada kay di kita swito. So anyway, off topic na ta. So let's go back to the problem. So this one is, I think, the same as the problem in the simple stress na atong gi-discuss before. But this time it's just restrained on both sides, meaning restrained. So if it's restrained, meaning it's fixed. Na. Restrained. Na. Meaning it's fixed. Okay. So again, if you're going to ask me why it's statically indeterminate, so if it's fixed, you have three different forces, diba? Moment. So wala siya arrow because we don't know yet the direction of the reaction forces, diba? Especially for the moment. Okay, but as far as we know, since we are presented with the 6 unknowns, then comparing it with 3 equilibrium forces, so meaning our member is statically indeterminate. All right. Now, now upon looking at the problem, so the rod is just having an horizontal application of horizontal forces only. So P1 and P2. So meaning there's no vertical load. So probably you won't be experiencing this one and this one. Diba? So no vertical load, no moment experience in the equation. But again, despite that these are all unknowns, it is still statically indeterminate. So just assume that there's no vertical load and there's no horizontal, rather moment. So tiba na ada horizontal load, diba? But it's just the opposite of the other one. It just cancels each other out. So probably this one is going up, this one is going down, diba? We don't know what the exact value is. Or let's say for the moment, this one is clockwise, the other one is this one is counterclockwise, the other one would be clockwise, diba? Just the opposite of the other. That's why it cancels each other out. But for the case of the horizontal component, since we have an extra added force P1 and then P2, so we can say that the reaction forces at both ends might be different compared with the vertical and the moment, which is just, let's say, of equal value because they cancel each other out. Okay, one of my other element presented in the rod, diba? Wala other vertical components and moment forces in your composite rod. So we focus more on the horizontal aspect. Okay, so as you might notice, more on discussion you go, diba? Okay, what akong experience mo before is that it's really a difficult subject na murag if dili siya properly i-discuss kay medyo maglibog yun ang student once you leave them on their own. So for example, karon kamo sige ra solve dire then without further explaining it in detail. So later on maglisod yun mo og sabot og unsaon siya pag decipher ang inyong problems. So that's why I try to scrutinize the steps as much as possible para nanamoy somewhat general guide ba on what necessary steps that you need to take sa kaning mga different problems sa statically indeterminate. Okay, mo taon na experience sa una, naglisod yung kuan sa strength of materials kaya amo teacher puro ra shortcut. Especially for example, makreate siya equation, let's say for the equation is inani katong the same ganina. Katong plus outer equals 1.1, di ba? Ang stasa mo teacher before, if tapulo na siya o discuss, yan na yung arrow down. Na, kahit lang 0.02, ana. Kahit lang ginana mo, marag magic ang last part sa solution. Yan kami, marag kami questions, kano mo siya inana. Or let's say to begin with, kano inana yung equation. Na, so wala inana nga pag-discuss before. That's why murag kami sa tagrado ato. Anyway, let's start off with the problem. So the same steps as before in your simple stress, katong mga composite rod. But this time we just have to add another force in the equation. So for example, this one is, so again, you may do it from left to right or from right to left. So it doesn't really matter, but for me, I just want to go from left to right. So again, if you're a fan of kanang mga Japanese comics, kanang manga, so you may do it from right to left, diba? Kaya that's how you read mga different comics sa Japanese, diba? One Piece, Black Clover, or kana pang Demon Slayer. So it's read from left. You're going to read it from left or right to left rather. So to start off, if you're going to cut the aluminum rod, okay, so this one is having a reaction. So let's say this one is reaction 1 lang siguro. And this one is reaction 2. Or kung naamong other nga mga terms, so pwede ra sad siya, pwede mo magbutang og a sub x, di ba? Oh, let's say a sub x lang ta para di ta magsunod-sunod sa solution later. Let's say a sub x ta. A sub x, okay, it's on the x direction, di ba? And let's say this one is b sub x, the other end. So AB, so A nga restraint, B nga restraint, fixed point. So if this one is AX, so this one should be the force coming from the reaction, diba? Which is also AX. But in this case, instead of putting AX, we try to make it equal as the force inside the aluminum. So let's say that would be P sub aluminum, diba? Okay, since equal naman siya, diba? And we have to represent AX as in terms of the force in aluminum. Okay? So mag-ana lang siguro siya. So let's try to make it AX first in all of the segments. So next portion is that we go to the steel portion now. So dili na ko ipatas unang drawing ha. Ako lang siyang i-move okay para natay space sa ato ang pag-solve sa ato ang problem. So let's say this one is AX. Then our other external force is P1 should be 120 kilonewtons. Okay, so let's say 120 kilonewtons is a great force compared with AX. So again, on these parts, since we don't know the exact value of AX, so on yung button now, the perfect way to do it is just to assume kung asa pa dong ang ato ang force. So let's say AX is a smaller force. So let's say this one is now our internal force. So that would be, again, to exert more force sa 120. So let's say this would be 120 minus AX. Okay. So for the third one, so let's try, we now go to the bronze part. So again, I just made my drawing shorter ha, para natay space sa ato ang kuan. So 120 kilonewtons, then this one is 100 kilonewtons. And let's say this is AX still. So this now becomes 220 minus AX. Okay. So notice that again, all of the forces being experienced by these portions are now considered to be part of the forces applied to your different materials. So let's say for example, di ba kaning AX, so let's say na siya value later on, is just equal to P sub aluminum, di ba? Sakto, di ba? So we can represent the numerical value of the reaction coming from AX as P sub AL. Sakto or di? So sakto, di ba? Kaya before, in our simple stress, we tend to have a value coming from one of the reactions. So muna directly, we can say that this particular value or numerical value is already the force behaving inside that particular member. So we can say that this one is P sub AL. So of course, this one whole thing again, 120 minus AX is equivalent to P sub steel. Same goes for this one, P sub bronze. Okay, so I think the best way to do this is, since they are all expressed in one particular variable A sub X, so probably we try to represent it in terms of one force. Let's say it could be aluminum, it could be steel, it could be bronze. But for in our case, it's better to represent everything with aluminum, because you just have to substitute the value of aluminum inside the equations for steel and bronze. So probably in terms of the aluminum force, this becomes 120 minus P sub AL, and bronze part would become 220 minus P sub AL. So pili siya niya na pagka-present, diba? I think it's much better compared with representing it as AX. Even though pili siya AX, but again, in the later part, pag sige po mo og substitute sa value sa AX sa kaning tulo ka book equations, di ba? If mag-AX mo. But pwede kaya po siya AX actually. But na lang siya problem later on if you try to do the compatibility equations. Sige, so let's try compatibility equations. So again, since, di ba, it's restrained, di ba? It's fixed. There's no movement. So meaning if you try to add up all the deflections coming from aluminum, deflection coming from steel, and deflection coming from deflection or other movement, bronze. So they are all equal to 0 because it's fully restricted. It's fully restrained. Excuse. Okay. So again, it's 0 because it's fully restrained. It's fixed. Okay, so we now have PL over AE plus PL over AE of steel plus PL over AE of bronze is equal to 0. All right. So this time is, I think we can incorporate, diba? The problem of using AX is that when we try to plug it in the compatibility equations, dito pwede magamit og AX, A sub X. Okay, the forces that the formula is implying is the force coming from that particular material. So pwede po AX kay eventually it's equal to aluminum, but again, basin basta ka mo na sa na pagkuhan. Basta para nako, it's better that it's referring to the force inside the material rather than the reaction force itself. So muna siya ako ang put pasabot. Okay, so to start off, you have the force coming from the aluminum, that's PAL, the same, multiplied by the length, which is 400 millimeters, divided by the area, that would be 900, and then 70 GPa. So I used GPA para akong force is in newtons, rather kilonewtons. So this time my P in the steel will be represented by this formula. So diba in terms of AL, okay, para instead of solving 3 unknowns, might as well I can solve P, the force of aluminum directly, diba? So next is 120 minus PAL times 250, the length, then divided by the area, that would be 1800 mm squared. Then the E for steel is 200 gigapascal. So just wrote 200. So again, ako lang siyang giplastanan, even though I don't know really the movement, if it's contracting or expanding, but regardless of unsay magawas nga answer, so mo adjust ra ang force ana. So it will just make the other terms negative if it's really that big of a number. So this one is 220 minus PAL, then times 300 mm all over 200, 2200, then multiplied by 83 gigapascal is equal to 0. Okay, so using shift solve, you can now solve for PAL.
Negative 110.87, sir.
Negatives, yeah?
Yes, sir.
Dapat tayo negative. Negative man eh. Sure siya nga negatives, yeah?
Yes, sir.
Wait sa mag natin sayop sa kwan. So this one should be negative ni siya, negative. Let's try to use the convention sa atong forces ha. If it's going to the left, it should be negative. If it's going to the right, it should be positive. So let's try to revert our answers ha. Let's try to correct our kuansa. Ato lang balihon na kay para kita dakog usbonon. So going to the left is positive. Ato lang iyan na positive na siya. Okay, ato mang i-declare ang 120 as positive manggod niya. It's going towards the left. Yeah, minus ang ato ang AX kay it's going to the right. So dapat bali dayon ta to. So going to the right is negative. Okay, so this one should be negative din siya. Negative. Okay, it's going to the left, di ba? Ba't di nato ibutang ang negative kay sige ato lang ibutang para kuan. Okay, so I think this is now correct. So kani siya is negative din siya. So i-correct to ang yung ano. So ako ra siyang gi-adjust according to the direction of the forces. So this one is going to the left, so that's why it's negative. Kani going to the right, that's why it's 120 minus a sub x. Going to the right, 220 minus a sub x.
51.203, sir.
Kanin mo muna siya ang correct answer. 51.20 no? Ano, siguro 20 lang. Kilonewtons. Now to solve for the other forces, so you just have to utilize the formula for steel. So P steel is equal to 120 minus 51.20. So this would give us, pila man na siya?
8.8, sir.
Pila to? Pila? 68?
68.8, sir.
0.8 kilonewtons. And then for bronze, this would give us 220 minus 51.20. So 168, no?
0.8, sir, yes.
0.80 kilonewtons. So you now have the three different forces coming from aluminum, steel, and bronze. So ako ang wrong kanina, ako ang wrong. Kaya ako may nagsulat. Kaya ang katurang pag take into account the the signage of asa akong forces. Kaya kalimot ko nga ang left ana. So if you try to solve this one again on your own, so try shifting it from kwan siguro ana. Ang inyo siguro ang button is ang going to the right is positive, then going to the left is negative if you want to remake this problem on your own. So instead of this one being 120 minus AX, so probably it becomes AX minus 120. Siguro siya. The other one is AX minus 220. If you try to revert the signages. So right positive, left negative. Okay, so calculate the stress in the different materials. So since it's referring to actual stress because there's no other reason that it will experience shear stress. So diretso na siya pag solve using force over area ng mga formulas. So starting off with aluminum, that would be force over area. And this is 51.20 all over 900 mm squared. So again, try to make it into newtons para ang gawas is megapascal. Then this one, so usually ang stress is megapascal, ang modulus of elasticity is gigapascal. So again, force over area, and then this one is 68,800 divided by 1800 mm squared. Then for bronze, this becomes, so again, force over area, and then you have here 168,000 all over the area, which is 2200. Sige, so unsa na yung answer niyo dia?
56.89, 38.22, then 76.73, sir.
76.73 megapascal. Okay, so dali na kayo siya, no? Dali na kayo siya pag solve sa mga problems. So again, if you try to summarize what we have done so far with this problem, so if you try to look at it, marag wala kayo tay equilibrium equation, di ba? Because we analyze it first, ang atong equilibrium equations. Katong kaning starting from left to right. So again, depende sa yung comfort kung asa mo mag-start. But again, you may start with equilibrium equations and then compatibility equations. Okay. So today is we started with equilibrium equations because muna siya ang style sa pag-solve diri sa problem, di ba? From left to right, from right to left. Which is normally we try to deal with the equilibrium force first before the compatibility equations. So diri ta una. Then this is for the next one. Then lastly is this one. Okay. So again, just try to take note of the direction of the forces. Kung asa inyo gi-declare padung inyong forces. Kung asa padung ang positive, asa padung ang negative. Okay, so this is the whole solution if you want to do it on yourself. So I suggest that you try to replicate the problems again, and then try to discover it on your own. Okay, para na may gamay na muscle memory. Okay, so this is the reaction. So again, if you want to start off with the equilibrium equations, you may do so. And you may start from left to right or from right to left. It will depend on your style kung sa inyong gusto. So in this case, it's starting from left to right. Okay, so this is, so again, the total deflection is equal to 0 because it is fully restrained, fixed at both ends. Okay. So this is how we solve the stresses. Okay, so for probably I'll just give this one as part of your assignment. So since we don't have time left, usually ang next teacher is kanang sayo kay siya mo login sa Zoom account. Ang next teacher bamot kasi na next teacher basta dali kanang sayo kay siya mo login sa Zoom account and then muna ma-auto kalit sa akong Zoom. I'll try to dismiss earlier lang siguro mga 15 minutes before naman. So I think pwede na siguro ron. So probably mga 10-20 mo dismiss na ako kay para kuan. Basta ba sayo kay siya mo sud sa klase. Ano na siya. So anyway, I'll just try to summarize first what you need to do in your assignment for statically indeterminate members. So muna, wala ko naghatag og assignment for simple stress and shear stress because mabalik yapon sila sa statically indeterminate members, di ba? As you can see here, di ba? Kani siya simple stress, kani siya nga topic. So nibalik yapon ta sa katon ng mga problems. So muna, para mausahan yung assignment, aral lang ko mahatag assignment sa statically indeterminate members. And again, this is the important part because it will again repeat itself or recur in the higher subjects. So kani siya, and then I'll try to also give this one to you. So I think you have this one in your statics but now subject. So may nga problems, diba? It's really statics of rigid bodies, but it's again statically indeterminate.
How many items will you give, sir? 5 items.
Probably
Assignment,
siguro
sir.
for this topic 10 guro. Okay, para mausahan lang siguro sa katong. So I won't give you assignments for simple stress and simple strain, but kanila siguro nga topic 10 kabo ka na. Okay, para at least kanang makakuha mo. But of course, I won't be giving you a difficult time, Jada. I'll try to choose kanang simple to hard para at least na may kind of progressive in your pag-answer ba. So starting off with a simple problem and then going towards the difficult one. Probably ang difficult siguro mga duha ra guro. 5 ka easy, di siguro 3 ka easy, 5 ka average, duha ka lisod na. Pero di pwedeng on lisod na super lisod dapat kana sa inyo ma-solve set. But kuan lang siguro it requires more time to think lang siguro na problems. Okay, so if you don't have any further questions, so again, midterm exam is we'll try to have the midterm exam before the Holy Week. Na, para at least maka-enjoy mo, maka-adto mo og Boracay baron or asa mo pa doong hindi ka Holy Week sa Bantayan Island, Camotes Island. So let's try to achieve that one because I want to discuss all the topics that is prior to the midterm exam. Okay, so questions or clarifications?
And so forth.
Okay, so if you don't have any more questions, so that will be it for this meeting. So see you all on Thursday. So thank you very much.
Bye, sir. Thank you, sir.
Sige,
Thank you,
goodbye.
sir.